So to start this lesson, lesson 96, we're going to look at angles. I want you to number 1, 1, 2, 3, 4, and tell me approximately how many degrees each of those angles are. Pause while you do it. All right, so I see that we all have answers. Now, if your estimate is within 5 or 6 degrees, that's a pretty good estimate. Did any of you guys have a plan on how you were going to estimate what you do? Or did you just look and go, I think it's this? Yeah? Okay. So what I want to do is I want to give you just one method that you can think about when you do these estimation things, okay? So here's what we're going to do. I am going to split this. Bloop, bloop. Here's what the book suggests. Let's take a circle. You can say standing for a little bit. So here's a circle. Now on that circle, I'm going to think about a clock. So if this is 12 o'clock, and this is 6 o'clock, straight down here, and this would be 9 o'clock, and this would be 3 o'clock, right? And now within this circle, if I think about this as thirds, maybe here would be 1, here would be 2. Close. We're estimating. 4, 5, 7, 8, 10, and 11. We good with that? All right, so now I'm going to group these all together so they stick together. Group them. Okay. Now, the center of this circle is approximately here. I should probably group that as well. Why might a clock help me? Yeah. We could take this clock and think about it as a 360-degree circle. So between each of the 5 minutes is how much time? This is bad, by the way. I'm going to try to fix it a little bit. Make it a little bit better. 1, 2. That's a little better. So every 5 minutes on a clock is how many degrees? How can I find that out? 360 degrees in a whole circle. There are 12 numbers here. So that means every 5 minutes on the clock is about 35. Does that make sense? Or 30 degrees. Sorry, not 35. You looked at me weird. So I knew I said something wrong. So let's take this clock. I have to shrink it a little bit. I'm going to use this clock as a protractor. So let's go to the first one here. Group. All right there. So now look at this first one. The first one here, from 1 to 2 is 30, and then it's halfway between here. So that's about 45. That would be my estimate, 45 degrees. Make sense? How many people said 45 degrees? Perfect. Now, in all reality, I look at that and go, okay, 90 degrees is here. That's about half of 90 degrees, so it's probably 45 degrees. Okay? But I can't do that with this one. Okay, so now I'm going to go this one. Group. Stop ungrouping. Okay. Here I'm at 11, and I'm almost to 12. Now remember, my clock is an estimate, so is that. Almost to 12. So let's just pick a little bit lower than 30 degrees. How about 28? Are you within 5 or 6 degrees of 28? We're going to measure these for real in just a little bit. So I'm going to say this is about 28 degrees. What'd you have? 33? 35. That's only 7 degrees away. That's not bad. 20? 20? We'll actually measure it and see how we did. So let's do the next one. Everybody just shout out. How much did you get for the next one? 90? Okay. This is stupid. Don't break apart. Okay. Okay. What happened to my 2? It stayed there? Whoop, there it is. All right, so I'm going to turn. Man, I'm going to turn it. Okay, I turned it. These should have turned a little bit too. Okay, good enough. Okay, so now we got that. I'm looking at 1, 2, 3, maybe a little bit over 90 or about 90 degrees. I'd say that looks pretty good, 90 degrees. That make sense? This is the last one. Drag it down here. Boop. Take the 1 and 2 with it. You know what? I don't even need those. I just need it here. So here we got 1, 2, 3, 4 full. 4 full would be 120. Halfway between be about 135 degrees. So an estimate here about 135 degrees. How'd you do on that one? That was our worst one. Let's see if we agree. 1, 2, 3, 4. 4 times 30. What did you guys have on that one?
120.
Okay, so it sounds like you do a lot better at acute angles than obtuse angles. Okay, but you know what? Let's see. Let's see what these things actually measure out to be. All right, so we'll grab this guy. We'll just take a quick measurement. Remember, you sit on it, and then you turn it. And I look at this, and it's 10, 20, 30. That's actually 40 degrees instead of 45 degrees. Pretty good estimate? Sure. Take this guy right here. That's about 91, 92 degrees. Pretty good estimate. Take this one right here. Spin that to there. 10, 20, that's about 28 degrees. We got 28 degrees. That's a good estimate. Let's look at the last one, the one you guys all screwed up on. Let's see, here's 90, 100, 110, 20, 30, 145. That puts you guys a little closer, right? So it's actually about 143. Does that make sense? If you like the clock method, use it. But here's a quick question. So let's write this down just because we should take some notes in this section. A couple things to write down. To estimate angles, think about a clock face. 5 minutes equals 360 degrees divided by 12, 30 degrees. So every 5 minutes is 30 degrees. So 1 minute would be 30 degrees divided by 5 equals 6 degrees. Whoops, not 60. Equals 6 degrees. So that is a good way to estimate angles, okay? Now, in all reality, what I do, I think about 90 degrees. And I use 90 degrees as my comparison. That's probably more what you guys did, right? And then use 90 degrees as a starting point for any and all estimation that I would want to do. Hey, Juliana. Glad to have you. You just missed estimating angles. Thank you. Make sure your phone is in your bag, and you'll be good to go. Any questions on that one? No? Perfect. So let's look at the second part of this lesson. The second part is a little bit harder part, okay? The second part is another property. We talked about the identity property of multiplication. Identity property of multiplication, you multiply by 1 and get the same thing. Identity property of addition, you add 0, get the same thing. Inverse property of multiplication is a number times its reciprocal is 1. What's the inverse property of addition? I don't think we talked about it. The inverse property gets you the identity. So like 2 times 1/2 gives you 1, which is multiplication. In addition, we got to get 0. So if I have 5, what do I add to 5 to get the identity, which is 0? -5. That's the identity. That's the inverse property. It's undoing addition. Okay. And then we have the commutative property. Commutative property says we can change the order. The associative property says we can change groups. The distributive property is next. So let's talk real quick about distributive property. You don't have to write this first part down, okay? I need a volunteer. Who is it? All right, Jonas, your hand went up. Here is Jonas. You have a really long neck, Jonas. Jonas! Got it? Jonas, what are you distributing? What are you giving people? You guys lining up for this one? All right. So Jonas is sharing hugs. So behind Jonas forms a line of people. Wow. Okay. So if Jonas is giving hugs, what does he have to give to this person? This person. This person. This person. So every one of them gets a hug. Does that make sense? That's distributing something. I was expecting Jonas to say like ding dongs or Twinkies or something. Okay? And then that's what he would do. He would give them each a Twinkie. Nice. Now, what does this look like with math? If I had 2 times 3 plus 5, and we followed the order of operations, we have choices here. Order of ops. I do this first. That's 2 times 8. 2 times 8 is 16. Now what the distributive property does, if it doesn't kick you out with an image of Jonas singing the line hugging people, which there might be a need for that right now. With Corona going on and like people not having physical contact, there could be a market for that. Set up a little booth, hugs, $1. So you get a creepy man that shouldn't be around kids, right? Okay, so we got the order of operations. And then we got distributive property. The full name of the distributive property, just so you're aware, is the distributive property of multiplication over addition. And what that would look like is it would look like this, 2 times 3 plus 5. We would distribute the 2 to everything inside the parentheses. So, since there's a plus there, we're going to put a plus here. And we're going to do 2 times 3. And we're going to do 2 times 5. There's a hug. 2 times 3, 2 times 5. It distributed, it goes to the things on the inside. So what happens here, now we get 6 plus 10. Which is 16, which is the same answer we had. Which is the exact same answer we had. Does that make sense? I hope it does. So basically now we can do this with, multiple different signs of numbers. So if I had, this is example number 2 in the book. Example number 2 in the book has 2 times x minus 3. It has negative 2 times x plus 3. I can't add x minus 3. I can't add x plus 3. Why? They are not like terms. Remember, like terms have the same variables, like terms. So, but what I can do is I can multiply. So since there's 2 numbers here, I'm going to have 2 groups. The subtraction, I'm going to have a subtraction in the middle. The first group is 2 times x. The second group is 2 times 3. What's 2 times x? 2x. Minus, what's 2 times 3? That's my answer. Can't add them, not like terms. Do the same thing here. How many numbers do I have on the inside? 2. So I'm going to have 2 groups, and they're going to be added together. -2 times x, -2 times 3. -2 times x is -2x plus, -2 times 3 is -6. And when there's 2 signs together, we can simplify that, -2x minus 6. Get rid of the disguise. Does that make sense? How about you try 2 on your own? I have, this time, on the outside is a -2. Treat it the same way, and then an x times x minus 3. Try the distributive property with those. How many groups do I have on the inside? 2. So there's my hint. It's going to be 2 with a minus on the inside. Same thing with this one. 2. Oops, don't put them together. If I put them together, that's multiplication with a minus on the inside. What are you distributing? What are you multiplying it to? I'll give you 20 seconds here. Do the best you can. 10 seconds. Camilla, on the first one, what am I distributing? -2. So it's -2 times x, minus is there, -2 times 3. -2 times x is -2x minus, -2 times 3 is -6, minus minus becomes plus, so -2x plus 6. That would be the answer. One step at a time. Oh, what did you have? -6. Do you understand why it's a plus? Good, good. Did you do the same thing, Sebastian? You had minus -6. Hey, you were close. Both of you were close. Is there anything you need to change on the other one? Here, I'm distributing x. So it's x times x, and it's x times 3. X times x is? Minus 3x. You had that one. Good job. You put it backwards. Why did you put it backwards? You don't have to distribute it either. You need to show the distributive step. I will get rid of that and make sure you show the distributive step. Okay, now, this one right here is going to cause you troubles in the next set of problems we're going to do. So have a seat and take a look at this. I've done this enough to know this is where the trouble's going to come. I'll do one of them with a positive, I'll do one with a negative. We have x squared plus 2x plus 3 times x minus 2. I want you to simplify this, okay? So now remember simplifying. You don't have to draw this. I'm going to put it in yellow. You don't have to draw this, but we have this idea of separation between terms. So here's one, here's one. This is all being multiplied, so I'm not having much of a separation there. What number is being distributed here? 3 to this, right? So I'm going to look at it. I got 2 numbers, parenthesis, 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 parenthesis. It's being subtracted. The 3 is being distributed. It's 3 times x, and it's 3 times 2. Nothing happens with this, so I'm going to keep it. X squared plus 2x plus. Do my multiplication. Nothing happens here. Nothing happens here. Plus 3x minus 6. What two things can be added in this one? The 2x plus the 3x. So, x squared plus 5x minus 6 becomes my answer. We can't add any more because there are no more like terms. Got it? Now, pay special attention to this. There was a plus 3. What happens if there was a minus 3 here? How would that change this problem? Yeah, this would have been a negative 3, this would have been a negative 3. That's what it would be. Okay, so now that you've seen that, guess which one you get? You get the exact same problem. X squared plus 2x minus 3 times x minus 2. See if you can do that one. Try. Okay. Now, what I did here is I separated it. I'm going to take this piece right here, and I know it becomes this. Because negative 3 times x is negative 3x, negative 3 times negative 2, negative 3 times a 2, with the minus here becomes a positive, okay? So if I come over here, I get x squared plus 2x plus, because remember, this is really plus and negative. Negative 3 times x minus negative 3 times 2. X squared plus 2x plus negative 3x minus 6. X squared plus 2x minus 3x minus 6 plus 6. Because that's minus a negative, that becomes plus. Because I use this to double check. And then I can add these two. What's 2x minus 3x? Negative 1x. X squared minus 1x plus 6. You are going to mess these up for a while. I understand that. One of the things that often happens is people here, they put a minus here. Because up here, remember, this was a negative 3. If you put a minus here, then you've got to really think about what you have. This is going to be a positive 3, but then it's going to be a negative over here. Okay? A couple other things, so remember our lesson of algebraic addition where you always add the opposite when you see subtraction? That's what you can do to help yourself do these correctly. We could also, you can see, if you lose the negative, something you can do is you can focus on minus 3 times x minus 2. You can focus on adding the opposite. Adding the opposite would look something like this. I'm going to use red. Plus a negative 3 plus a negative 2. Now what that does is that helps you keep it all in order. X squared plus 2x plus negative 3 times x plus negative 3 times negative 2. It's a slight change, but it's a change. X squared plus 2x plus negative 3x plus 6. And then I can add these to simplify it. The negative will give you trouble, so I'm saying caution. Watch those negatives. Let me give you one more. Let me give you one positive, simple one, and then one negative, harder one. Let's go with x. Ooh, yeah. Let's go with x squared plus x times x minus 3. Take care of that one, and then I'll put another one up here for you. There's your second problem. Solve those two. All right, let's take a look at how you did. If I had even half of you get these both right, I will be surprised. Because I understand this lesson can be, it seems easier than it is with that negative. Okay? So, no worries about it. You don't have to know it. This is tomorrow's stuff anyway. So as I look at this, we got x squared. I can focus on this part here. X times x times 3. X squared minus 3x. X squared plus x squared, those are the only ones I can add. 2x squared minus 3x. We lost a couple. Lost a couple. Anybody want to share what? What do we need to watch out for? Yeah. Oh, but that's only when you multiply, right? Good catch. Yeah, x squared plus x squared. 1 inch squared plus 1 inch squared is not 1 inch to the 4th. Yeah, good. Okay, so if I did this the other way and I changed this to plus and negative, we would have x squared plus x times x plus x times negative 3. So x squared plus x squared plus negative 3x. Then we simplify 2x squared minus 3x. That way it works as well. So, take a look at this one. Nothing happens, nothing happens. Let's just focus on here right here. I'm distributing negative 8. So, negative 8 times x plus negative 8 times 2. All right, so then this becomes 2x squared plus 3x plus. So 2x squared plus 3x minus or plus a negative 8x plus a negative 16. Now we simplify. 3x plus negative 8x. Negative 8 plus 3 is negative 5, because the signs are different, we subtract. 2x squared minus 5x minus 16. Lost a couple more. Losing a couple more still. Yes? You didn't simplify it. Gotta get rid of the double signs. Gotta get rid of the double signs. Plus a negative, that's what he said too. Yeah, plus a negative 5. Gotta get rid of the doubles. Okay, we shouldn't have two signs together. So we got 1, 2, 3. I was right, less than half. Yes? Same thing. Plus a negative 16 can simplify to negative 16. So we don't want to see two signs together. We can use two signs to help us solve it, but not in our answer. Perfect, have a seat. Looks good. So that being said, let's take a look at the practice problem from lesson 94 that we haven't done yet. Open up your book to page 656. I believe we did A, B, and C already. I think I assigned B and said do it, and then we'll check this morning. It's 360 inches squared, or centimeters squared. B was 360 centimeters squared. If you need help with that one, let me know. But let's look at D and look at E. Problem D. Volume. First thing we're going to write down is volume equals base times height. And then we draw the base. Now this is a compound base we talked about the other day. It's the L, or the hexagon. So now as I look at that hexagon and I want to break that hexagon up, I might be better off served drawing the full hexagon, saying it's 7, 5, 2, 3, where those go, 3, 5, 7, 2. So this becomes a 4 and this becomes a 3. That'll help me break it up. Now I see what I have. I don't have a formula for that, but I can divide it right here. That gives me a 3 by 3 and a 2 by 7. Area equals length times width. In this case, length is 3 and width is 3. Area equals 3 times 3, which is 9. Over here, length is 7, width is 2. 7 times 2, 14. So 14 plus 9 is 23. That's my B. What's my height? How many layers does it have? Sure. If we look at that bottom number, it's 10. So height is 10. So volume equals 23 times 10. Volume equals 230. I guess they're all in centimeters, so this would be centimeters cubed. Because here you got centimeters squared. If you want to see the math, 23 centimeters squared times 10 centimeters. That's 23 times 10 centimeters squared times centimeter. That's why it's centimeters cubed, 230. Volume equals base times height. E. Volume equals base times height. There's my base. What's the area for the base? Area equals pi r squared. R is 1. Area equals pi times 1 squared. Area equals 1 pi. Equals base. How many layers? So volume equals 1 pi times 10. Volume equals 10 pi centimeters cubed. Let me make sure that's not Miss K. That was like 5 beeps. It was Mr. Richter. So it must not be school related. Done. Make sense? I will look at break. Ah. A farmer added an attached shed with the dimensions shown to the side of his barn. What is the approximate value of the addition? List the steps needed to find it. Now, I don't want to multiply 7 feet 11 inches. Approximate means we estimate, right? What shape is my base? The quadrilateral, special quadrilateral called a trapezoid. But we do the same work. Volume equals base times height, and I'm going to draw my trapezoid. If I wanted to, I could go with what was said. I could take this rectangular squarish thing, but I'd also have to take the triangle that goes with it. So I could do it in 2 pieces, but since I have a trapezoid formula, I'm going to use it. 1910, what does that round to? 9 feet, 10 inches, what does it round to? So this here is 10 feet. 10 feet, 1 inch, what does it round to? 10 feet. I need this side right here. This is 7 feet, 11 inches, what does it round to? 8 feet. Perfect. What's my formula for a trapezoid? Very good. 1/2 the quantity of base 1 plus base 2 times height. Base 1, base 2, height. Base 1, base 2 are the parallel sides, 8 and 10. Height is the distance between them. 1/2 of 8 plus 10 times 10. Area equals 8 plus 10 is 9. 9 times 10 is 90. Equals what? Thanks. Good call. Height? How many layers? 20. 20 feet worth. 20. Volume equals 1,800 feet cubed. That is an approximation. Make sense?